So I am going to give you some numerical clarification as mentioned by the different students for brown stock washing system. So number of students are having the problem here in the basic concept. So I will take a simple example of real type of the industrial problem of doing the brown stock washing of pulp in paper industry, and we will see some of the basic concepts and how to find out the washing efficiency and dilution factor. That is the two very important parameters in brown stock washing in paper industry. So as you know, the washing is basically we are doing after pulping for separation of the black liquor from the pulp. So basically we are separating the black liquor and the fibers. So let us see the numerical here. So question may be given in the several variants, but so one of the variant is given here. So if we are having the concept clear here, you can use this one for solving the different types of the numericals. You can do the different solving here. So let us have the numerical here. First of all, I will give you the one problem that is similar to the problem asked in the internal exam. Right, so problem is like this one. Explain steps for calculation of dilution factor and washing efficiency of a BSW section in an integrated chemical recovery section handling 500 tons of brown stock slurry per day, which is diluted from 12% pulp consistency to 1 pulp consistency using the dilution valve. And the output washed pulp is having 15% consistency. Normally it's having the range in between the 12 to 16%. So in this numerical, it's given 15% consistency, and input pulp slurry has 18% dissolved chemicals, which goes to the black liquor. So amount of water used in washing is 3.0 ton per ton of the OD pulp. That is the extra water that's being used in the washing through the showers and dilution. So assume any other data if required. If there is a requirement, you can assume the justified data here. So let us start the first step. As per the definition, first of all, we have to find out what is the dilution factor. So you have to write the equation here. Dilution factor is defined as the mass of wash water added to a washing stage minus mass of liquid leaving wash, and the mass of the water added the wash should be in unit mass of people. So in this case, being added or living of the system, every time we assume the certain amount of body that is coming in the system along with the brown three important components. The pipes that are, then is the water, someone is quantity of water. So fibers will be on the top of the screen, on the surface of the rotary drum filter, and the black liquor is passing through the porous media or screen of the brown stock washer. So black liquor will be having the water plus dissolved solid. So here you can see mass of the liquid leaving with the washed pulp will be calculated by taking the amount of water, basically 100 minus 15 upon 15, because 15% is solid. For every 15 ton, there is a 100 minus 15 ton of the liquid is there. So this unit will be the ton per ton of the OD pulp. And this will be coming 5.6 ton per ton of the OD pulp. And from given in problem, mass of water added to a washing stage is equal to 3 ton per ton of OD pulp. Right? That means for every ton of the oven dry pulp that is being washed in the system, we are adding 3 tons of the wash water. So using the formula of dilution factor will be equal to 3. That is coming here. The 3 ton is mass of water added to the washing stage minus 5.66. That is the water leaving the washing system along with the washed pulp. So here is coming minus 2.66. That's why all the dilution factor can be positive, 0 and negative. In our case, in this numerical, we have taken the negative dilution factor. That means we are basically concentrating the black liquor by certain amount. That means whatever is the water that is coming along with the pulp in the input line, we are increasing the concentration of the black liquor. So coming to the second part, again the percentage efficiency of a washing system, it is equal to the dissolved solids going to evaporator per ton of the OD pulp multiplied by 100 divided by the amount of dissolved solids initially present in washing system per ton of the OD pulp. That means how much is the dissolved solid that is leaving the washing system and going to evaporator divided by the amount of dissolved solid that was initially present in the washing system, or it was in the input of the washing system. So amount of black liquid the input to washer is given in the numerical. It's 500 tons, and in black liquor at inlet is equal to 500 multiplied by 12 divided by 100. Because given that 12% is a solid in the black liquor. So you can calculate the amount of the solid, and this solid not the dissolved solid, which is the solid which is defining the pulp or fiber. So this is the basically quantity of the fiber here, OD pulp in the black liquor, that is equal to 60 tons. So liquid in the black liquor at input to the washer will be equal to total quantity. So given the numerical 500 minus 60, 440 tons. Again the input black liquor has 18% dissolved solid as given in the numerical here. So dissolved solid in the input black liquor will be 440, that is the quantity of the liquid coming in the black liquor here multiplied by 18 divided by 100. That means out of the total black liquor, 18% is solid. This will be coming 79.2 tons. And if we are calculating for per ton of the OD pulp, then total pulp is a 60, so we will divide by 60 here. So it will be coming 1.32 ton per ton of OD pulp. Now we have to assume the amount of soda loss, because soda loss is a reality. Every time there will be some loss of the chemical due to leakage from the glands, then pipelines, again from the pumps, and due to the spillage again. And it's having the sometimes a problem in the washer. So we are assuming the 50 kg per ton of the OD soda loss. So dissolved solid going to evaporator will be total dissolved solid 79.2 tons minus 50 ton multiplied by 60 is the amount of the pulp. So 50 into 60 divided by 1000. So 1000 we are dividing to make the kg converted to tons. The first one is in the ton. Ton is equal to 1000 kg. So once we are dividing the kg by 1000, it will be converting to ton here. So it will be 50 multiplied by 60 divided by 1000. And it will be coming 76.2 tons here. And if we want to convert it to the per ton of the people, that is to divide 68 because total quantity of the oven dry pulp is 60. So 76.2 divided by 60, it will be 1.27 ton per ton of OD pulp. So now again we can use the equation 2, that is the definition of the washing efficiency. Efficiency of washing will be equal to 1.27 divided by 1.32 multiplied by 100. So 96.2%. That means this washing system is having the efficiency of 96.2%. That means 96% chemicals, dissolved solid is recovered and sent in the form of the dissolved solid in black liquor to further processing to the evaporator house in the chemical recovery section. So this much quantity of the dissolved solid will be going to the evaporator section, and the rest of the amount is basically lost in the process, and mainly it's going along with the washed pulp. So that is the basically loss of the chemical. So in this way, we have covered a lot of the parameters, especially related with the washing process of the unbleached pulp or brown stock, which is coming from the digester. Okay, thank you.